We are going to talk about an interview problem, that is sort zeros, ones, and twos. It is a sorting problem in which we are giving an input in terms of 0, 1, and 2, and we have to sort in the ascending order. But the expected time complexity is order of n, and auxiliary space is order of 1. If we use the normal sort method, it will be n log n, so we have to optimize that. And if we use a temporary array, then also it is going to need uh, auxiliary space, so we cannot do that. The most efficient way to do this is the Dutch national flag algorithm. Let's see what is the Dutch national flag algorithm. Basically, we have three pointers: low, mid, and high. All the zeros are stored in 0 to LO minus 1, low minus 1, and the ones are stored in low to mid minus 1, and the unknowns which are not yet discovered are stored in mid plus 1 to HI, and HI to the end of the array contains all the twos. So that is the basic idea, that we keep all the twos at the last and zeros before LO, and the ones between low and mid. So let's see a dry run of this particular array. The yellow part is the mid, green is low, and this is high. So we initialize like low and mid as equal to 0, because at first everything is unknown, so mid is 1, mid is 0, and there is no zeros in front of LO, so LO is also 0. And the high is at the last, because uh, there are no twos between last index and high index, so that's why high is last. So let's see the working of this. So if we compare array mid with every element, so array mid is 1. If it is 1, we simply increment the mid pointer. So here the mid pointer goes here. Now the array mid is equal to 2. At this point we swap it with array high. So array high is swapped with array mid. So 0 comes here and 2 comes there. 0 comes here, 2 comes there, and then we decrement the high pointer, because now the twos should be between high to end of the array, so high must be lowered. That's why high comes high minus minus, and the array mid contains that only, remains there only. Then mid is 0, so if mid is 0, then we swap it with array low. So here we swap with array low, and we increment low as well as mid, so low plus plus and mid plus plus. Now again it comes 2, so we swap it with array high. We swap it with it, to 0 comes here and 2 goes there, and we decrement the high pointer. Now 0 comes, so we again replace these two and increment both the pointers. 0 here, 1 there, low plus plus, mid plus plus. Again the array mid is equal to 0, so 1 goes here and 0 goes there, and we increment both the pointers. If array array mid is equal to 1, then we don't do anything, we simply increment the mid. Why we do that? Because uh, between LO and mid all the ones are stored, and if there is a 1, that needs to be between low to mid minus 1. That's why we increment mid. Now again 0 is encountered, so we replace it with LO and increment low pointer and mid pointer. Now again 1 comes, so we increment, just simply increment the min pointer. Now high is less than mid. When high is less than mid, we stop the array. That means that all the unknowns are now known. So we have processed the array, and look, the array is now sorted with one traversal. The time complexity is order of n, and the space complexity is theta 1. So we are going to code that. So low is 1, mid is 0, and high is also. High is array dot size -1. If array mid equals to 0, then we simply swap array mid with array low, increment low and increment mid. Array mid is equal to 1, then we swap, then we don't swap, we just increment the mid. Else swap array mid with array high, and this. Yeah, that works. So let's check if we are getting any errors. Yeah, this solution works. So yeah, this is the Dutch natural flag algorithm. It is also used for sorting when a number is given and we need to like pivot that. Like suppose we have given a number 5, and we need to we need all the elements less than 5 to be at one side, all the elements greater than 5 need to be at one side, and all the fives in the middle. So then also we use 3 pointers and separate that. This is called three-way partitioning. It is a popular problem. Another problem that is based on this is the range problem, like between 5 to 10. If we want like all the elements smaller than 5 to be at one side, 5 to 10 at their correct position, and all the elements greater than 10 should be at the right. Note that it does not mean that the array will be sorted. It just means that the positions between 5 to 10 will be at the middle, and lower than 5 would be at one place and greater than 10 would be at another place. So we can do that just by simply here we can just say like array mid is less than 5, as if array mid is greater than or equal to 5 and smaller than or equal to 10, and else part, then that solution works here. So it is based on the same algorithm, and it has many applications. So this was the video about Dutch natural flag algorithm. Stay tuned for many such videos. Thank you for watching.